So this is going to be a lecture on naming functional groups. So we spent most of the other videos doing your hydrocarbons. Now we're going to involve things with oxygen and things with nitrogen. So on the top of your notes, write IUPAC. It stands for the International Union of Pure and Applied Chemistry. This is a naming system that we will be using for most of the functional groups, but there's also what we call a common naming system as well, but I'm only going to expect you to know one of them. So I'm going to go through each one of the functional groups and show you an example. The good news is it follows the same rules as the alkanes, alkenes, and alkynes. It's just now we're talking about more specifics in terms of the functional groups. So we're going to start with alcohols. Alcohols are, of course, anything with an OH. So there are two different naming systems, and you do need to name where the OH, it's called a hydroxyl group. That's what OH stands for. We're going to use the IUPAC system, and because it's the easier, and I always try to pick the easier of the two, just because I don't want it to become a memorization game. So if you have one carbon and it has an OH, it's going to be called methanol. So what you do is you call it the methane, you drop the E, and you end it in OL. Okay, so you call it methanol. If you have two carbons, you're going to call it ethanol. Again, dropping the E of ethane and put in OL. So this one you have to draw in the OH. Okay, the OH happens to be off that middle carbon. This is what we call 2-propanol, because I do need to name where the hydroxyl group is located. So this is where it starts to get interesting, because you can put it on different parts of the carbon once you get to 3 carbons. Now 2-propanol is going to be an easier naming system than the common name, which is called isopropyl alcohol. Because again, if you look at this column here, methyl alcohol, ethyl alcohol, that sounds okay at that point. But then you start to get into other common names that become a complete memorization job. Isopropyl you might know as your rubbing alcohol. That's the alcohol you probably have at home in your medicine cabinet for cleaning out cuts or anything like that. So let me draw a molecule and then I'm going to name it. Then I'm going to name it. Okay, so just like other naming systems, if you had a double bond or a triple bond, you always start wherever that happens to be. So I have 4 carbons in a row, and I'm going to start not where the bromo is, but where the OH is, because that's going to be the dominant partner here for this. And I'm going to circle these numbers just because it's going to get a little confusing because it's more of a condensed formula here. So I have 4 carbons in a row, so it's going to end in butanol. Okay, and I have to tell the reader where that OH happens to be. So I'm going to do a 2-butanol for that OH off of the second. Again, the bromo is here off of the 4, so I'm going to put a 4-bromo in front of that. And again, any other branching you would have is going to follow the same set of rules as we learned before. So again, once you learn alkanes, everything else kind of flows. It's just additional information that you have to put in there. Now, in addition to naming the alcohols, I'm just going to ask you to tell me if it's a primary, secondary, or tertiary alcohol. If I draw an alcohol, what matters is what is it attached to, that carbon. So if I draw this carbon with 2 other hydrogens where the OH is, and then I'm going to have more carbons off of this, this is what we call a primary, okay, alcohol. Why is that important? Well, the OH is going to be on the end of the molecule somewhere. And that alcohol is going to have much more reactive properties because that functional group, that OH, is going to be what the chemistry is going to be looking at. If I look at something called a secondary, what that's going to look like is you do have an H off of that carbon, but now you have 2 other carbons coming off of that. So I'm going to draw an example down here so you can kind of see what it would look like. So this OH is attached to this carbon, which has two neighbors of two different carbons and then a hydrogen. So this is what we call a secondary. And sometimes you will see it abbreviated SEC, okay? And sometimes you see it in the naming, a different naming system. Not going to go into that, more of just trying to recognize what kind of alcohol do you have. And finally, the last option is going to be where you have an OH kind of in the middle of everything, okay? So if I have a OH off of this carbon, it's got to have neighbors on all sides, okay? So this is what we call a tertiary, I'm probably saying it wrong. It is abbreviated TERT, T-E-R-T, okay? Again, this OH is going to be kind of in the middle of stuff, so it's not going to be as what we call reactive as some other alcohols. All right, so flip it over to the next page. We are then going to name ethers, okay? This one, I'm just going to give you the common name. It's the most easy out of the systems we have. Remember, ethers, oxygen is between a number of carbons, however many carbons that you have, it doesn't really matter. So you're going to name the alkyl group in alphabetical order and then call it an ether. So if we look here, this is my ethyl group, and this is my methyl. So you're going to call it ethyl methyl ether. Ethyl comes before methyl in the alphabet, so that is why you have it that way. Here versus here, I have diethyl ether because both of these are ethyl groups, so you do it that way. So sometimes what you're going to see with ethers is more of a condensed formula because you could just put so many carbons on one side or the other. Okay, so copy down this formula here. So if I put parentheses around a CH2 group and I put a number on the outside, that just means it's repeating CH2, CH2, CH2. So I have a total of 4 carbons on this side. So that's going to be a butyl group. And then here I have 4 plus another one, that's a total of 5, so it's going to be a pentyl group. All right, who comes first in the alphabet? Butyl, okay? So you're going to call this butyl pentyl ether. All right, and of course you can have branches on this. So let me draw a smaller one just to make it a little easier to see. So what if I had a bromo there, okay? So again, this is an ethyl over here. This is a methyl. So who comes first in the alphabet? Again, that would be bromo. And you do want the bromo next to the ethyl, okay? Because that's where it is located. So it's a bromo ethyl methyl ether. All right, and then let's finish up with aldehydes. So aldehydes are going to be what we call an end group, okay? And that is going to lend itself to some differences in terms of how things are done. We are going to use the IUPAC system for this because it's far easier than the common name. So the simplest aldehyde is a C double bond O, H, and then you have another H. So it's called methanal. So you're going to name the alkyl group and then end it in al. So you're going to call it methane, drop the E and put an al at the end, okay? Now the common name is called formaldehyde. Again, that would require a lot of memorization, so we're not going to do that. Then we have ethanal, okay? C double bond O, H, that's what makes it an aldehyde, C double bond O, H. And then we have another carbon. So we have a total of 2 carbons. So it's called ethanal, ethanal. So draw one more down here. Now, alcohols, you had to put a number. Because this is always going to be the #1 carbon, we don't have to use numbers in this system, okay? So write down no numbers for aldehydes, okay? No numbers are needed for aldehydes because it's always going to be the first carbon, no matter what. Even though the bromine here, you don't start numbering over here, okay? So this is always going to be the rule for all of the functional groups if they can be on other sides or different places in the molecule. So the functional group is always going to be the #1 carbon, okay? So this is going to end in butanal, okay? Butanal, butane, drop the E-A-L. Again, you do not need to write a 1 there because it's always going to be on the end group. And then you just call it 3-bromo butanal, okay? 3-bromo butanal.